Let's get started today with section 1.3. All right, the first thing we're going to do with section 1.3 is define the midpoint of a segment. So if we draw a segment here from A to B, and we put a point here in the exact center of it. Now, I know that's not the exact center, it's just my drawing, and we call that M. We would say that M is the midpoint of AB. And notice now that we have two segments, AM and MB. And we would say that AM is congruent to MB. Because if that point M is exactly in the middle, it now divides that segment in half. It's like cutting it in half. So the midpoint of a segment is the point that divides the segment into two congruent segments. And now sometimes the midpoint is not always going to be like a point. It can also be another line, it could be a ray, it could be another line segment. So anything that goes through a line segment at its midpoint is called a segment bisector. So a segment bisector is simply something that intersects a segment at the midpoint. And just to give an example of that, we can have a line segment right here. We'll also call this guy AB. But instead of having our old point M be our midpoint, we can cut AB in half with this green line right here and call that green line DC. And now this segment is intersected right here at point M and is congruent from AM to MB. So we would say that the line CD is the segment bisector. All right, so just a quick little example if you're following along. If we go and draw a line segment right here and we call this guy XY, and we cut this guy in half like so, and we cut it in half with another segment VW and intersects here at T. I want to find the length of the entire segment XY. So we want to find first x, y. And so xt is equal to 39.9. And we know that VW, that line segment, bisects segment xy at point T. And we know that xt is equal to 39.9 centimeters. And so since VW bisects xy, we know that xt is congruent to ty. And so we'll draw that in red right there. And so we also know from last time that the entire length of xy is equal to xt plus ty. And so we could replace that with xt plus xt, or 2 times xt. So xy is going to be equal to 2 times the length of xt, which is 39.9 centimeters, and that is going to equal 79.8 centimeters. And now, unfortunately, life cannot stay simple all the time. I wish examples like that could stay simple, but that is not the case. So let's do a little bit more of a complex example. So we have VW on the outside, and it is intersected here in the middle by M, which is the midpoint. And now V, M, and MW are congruent. We know that because M is the midpoint. And we are given the length of VM as 4x minus 1 and the length of MW as 3x plus 3. And we want to find the length of MW. So we want to find that right segment. So we must first find our unknown variable x. And once we know x, we can plug that into the length of MW, because we're technically already given the length of MW as 3x plus 3. But we don't know what x is, so let's first find x. So we know that VM is equal to MW. They're congruent, the lengths are equal. And so we can set their two terms equal to one another. So 4x minus 1 is equal to 3x plus 3. And now we just have to use our algebraic inverse operations to solve for x. So we're going to subtract 3x on both sides to combine like terms. 4x minus a 3x is going to leave us with 1x. And so we have an x minus a 1 is equal to 3. And then we're going to add 1 to both sides to get x is equal to 4. Now, if you're taking a multiple choice exam, I guarantee one of your answers is going to be x is equal to 4. But that is not what we want. We need to take this x is equal to 4 and plug it back in up there because we want the length of MW. So remember that MW is equal to 3x plus 3. And so we're going to plug in x is equal to 4 into that equation. So we're going to have 3 multiplied by 4, because that's what x is equal to, plus 3. And 3 times 4 is equal to 12, plus a 3 is equal to 15. So MW is equal to 15 units. Now, the midpoint, as you can see, is very valuable to us. It allows us to find lengths of segments. And we can actually find the midpoint on the coordinate plane. So we have what is called the midpoint formula. And so if I were to give you a coordinate plane over here, and this is going to be a very abstract coordinate plane, imagine this is just our upper right quadrant, quadrant number 1 on the coordinate plane. And say there's a segment in this coordinate plane, A, B. And A is going to be at some point. Let's call that point x1, comma, y1. And B is at another point up here. Let's call that x2, comma, y2. Because we need this to generically apply to all segments within a coordinate plane. We know that M is going to be somewhere in between A and B. And the midpoint formula is actually going to be the average of our x and the average of our y. So notice you could take x1 and add to it x2, divide by 2, and that is going to be our midpoint, right? Because we're going from here to here, we're going to be right in the center of our x's. And our y's, we can average those together. So y1 plus y2 divided by 2. And that is going to be the center of our segment. So that's our midpoint formula. So M, the point M is equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And now there's a couple of different examples we can do with this. We're going to do example number 1, which is going to say the endpoint RS is R is the point 1, negative 3, and S is the point 4, comma 2. I want to find the midpoint. So if we draw out a coordinate plane here, and put on some tick marks here, and then put on our segments. So we're going to go to 1, -3, and that's going to be point R, and 4, +2, that is going to be S. Connect those. We can see that our midpoint is going to be somewhere right in here. So let's actually use our midpoint formula. So we are given that we have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And so we have our point R, which is going to be 1, -3. Let's use that as our x1, comma, y1. And we also have the point S, which is 4, comma, 2. Let's use that as our x2, comma, y2. And now we'll plug those into our midpoint formula. So m and x1 is 1 plus x2 is 4 divided by 2. And y1 is -3. y2 is a +2 divided by 2. And I wish we can leave things like that, but we do need to simplify. So 1 plus a 4 is 5. 5 divided by 2 we can leave as 5/2. Or you can simplify that to 2.5. And then -3 plus a 2 is a -1. -1 divided by 2 is a -1/2. So our midpoint is actually at 5/2, 2.5, -1/2. So our midpoint is right there. Our second example is going to be a little bit different. We're going to be given the midpoint of a line segment. So the midpoint has the coordinate m, which is equal to 2, 1. And we are looking at segment JK, and all we know is endpoint J, which has coordinates 1, 4, and we need to find the coordinates of K. And so if we go ahead and draw this out on the coordinate plane, it's a huge coordinate plane, we don't need it that big. All right, we know that J is going to start at 1, 4 up here. And we know that the middle of this segment is at 2, 1, M. And so if we draw this segment down, we're going to approximately go this length down there. So we need to find where K is. So if we imagine this segment right here as J as 1, 4, M as 2, 1, right? Because that's at 2, 1. And then K is going to be at something, something. We just don't know what those somethings are. Now, notice that the difference between 1 and 2 is a +1. So if we add 1 there, we should be up to 3. And then the difference from 4 to 1 is subtracting 3. So if we subtract 3 again, we'll be at a -2. So K's point is, in fact, 3, -2. I know the scale's a little off, but the practice is still there. Next, we are going to do what is known as the distance formula. And the distance formula is a little bit confusing at first, but once you get it down, it does come a lot easier. It helps you finding distances of segments. So that's going to be AB. And we're going to say that the length of AB is going to be x2 minus x1 squared plus y2 minus y1 squared. And so that's the distance formula. The same properties apply, and x1 goes in the x1 spot, x2 spot, so on and so forth. And so if I were to give you a coordinate plane here with a segment in that coordinate plane, and let's say this segment is RS, and we have R at the position 2, 3, and S at the position 4, -1. And then we connect those two segments. If we wanted to find the length of RS, the first thing we need to do is denote an x1 and an y1 and an x2 and a y2. Personally, it doesn't really matter which one you choose. The answer will come out the same. So let's make our top one our x1, y1, and our bottom one x2, y2. And we just need to plug now into the formula. So RS is going to be equal to the square root
x2 is 4 minus x1, which is 2, and we're going to square that quantity, and then add to that y2, which is a negative 1, minus y1, which is a positive 3, and square that quantity. So 4 minus 2 is a 2, and we're going to square that. Negative 1 minus 3 is a 4, and we're going to square that, negative 4. And then we are going to go ahead. 2 squared is 4. Negative 4 squared is positive 16. And so this is going to equal the square root of 20. And if we plug that into our calculator, the square root of 20 is approximately equal to 4.5. So that's all you need to know for the distance formula. If you have any questions, please let me know.